Okay, question 7. AB is an air traffic control tower. There is a light source at B that shines a beam of light across the runway on the ground. Express angle CBD in terms of alpha. So angle CBD is actually in triangle CBD. I've drawn that in green there. So we're looking in triangle CBD. In triangle CBD, we are given that side BC is the same as side BD, which makes angle BCD an isosceles triangle. So if two sides are equal, that means that the two base angles are also equal in that triangle. So angle C is given to us as alpha. It would mean then that angle D is also equal to alpha. So angle C and angle D are both alpha each. So angle B then will be 180 degrees minus angle C minus angle D. C and D are 2 alpha together. So angle B will be 180 degrees minus 2 alpha. And your reason there is sum of angles of triangle BCD. 7.2. Show that cos alpha is equal to x over 2 into x minus 1. So, usually when I see cos alpha, if I don't have a 90-degree triangle that I can use alpha in this case angle BCD is the one that has the alphas, but it's not a 90-degree triangle. So I'm going to look for the sine rule or the cosine rule. The cos alpha is a clue for me to use the cosine rule. So in triangle BCD, the angle that I'll use is angle C, which is alpha, so I can get my cos alpha. If the angle I'm using is C, I have to start with small c. If you remember how to label your triangle for the sine rule and cosine rule and area rule, you remember that opposite the angle capital B, you write small b next to that side. Opposite the angle capital C, you write small c on the opposite side. And opposite angle capital D, you write small d on the side that's opposite D. Right, so if we using angle C, we need to start with small c. So small c squared is equal to b squared plus d squared minus 2bd cos of angle C. That's your cosine rule from your data sheet. Okay, fill in, substitute everything that you know. So small c is the x minus 1 as given there on the diagram. So x minus 1 all squared is equal to b is given as x, so x squared, plus d is given as x minus 1 because that's an isosceles triangle. So x minus 1 all squared minus 2 into bd, which is x times x minus 1. Cos of angle C is alpha. Okay, now it's just solving for cos of alpha. So we are going to isolate cos of alpha. So we have x minus 1 all squared. Let's take the other two terms over from the right hand side. So negative x squared minus x minus 1 all squared. That's going to equal to negative 2 into x minus 1 cos alpha. All of that is one term, remember. So you can't take that over. So if we want cos alpha now, we can simplify the left hand side. If you look carefully, you can see you have a bracket x minus 1 all squared. It's subtracting another exact bracket x minus 1 all squared. So those two brackets can cancel each other off. So on the left hand side, you have negative x squared that's left. So you have negative x squared is equal to negative 2 into x minus 1 cos alpha. If you want cos alpha, you need to get rid of everything that's before it by dividing. So we'll divide both sides by negative 2 into x minus 1. So on the left hand side, you'll have negative x squared over negative 2 into x minus 1. That's equal to cos alpha on this side, which is what we wanted. All we need to do now is simplify the left hand side, and we should get the answer that they are expecting us to get there in the question. So I have x squared on the top. One of those x's can cancel with that x at the bottom. The negatives can both cancel off. And that's it. So we're left with x on the top. We're left with 2 into x minus 1 at the bottom, which is what they wanted. 7.3. if x is equal to 15 meters, calculate the height of the air traffic control tower AB. Okay, so we will look at triangle ABD now. So in triangle ABD, our angle there is alpha over 2, there at angle D. It's important to realize that a triangle ABD is a right angle triangle, as given in the question. So because it's a right angle triangle, we can use SOHCAHTOA here. So tan of alpha over 2 will equal to opposite over adjacent. Opposite will be AB and adjacent will be x minus 1. So tan alpha over 2 will then equal to AB over x minus 1. We can work out alpha from 5.2. In 5.2 we had cos of alpha equals x over 2 into x minus 1. But we now know that x is 15. If we substitute 15 into the answer from 5.2 and cos inverse that answer to get alpha, you'll get the alpha to equal to 57,61 degrees. So we can substitute that into this question. So tan of 57,61 degrees over 2 is equal to AB over 15 minus 1 because x is 15. So that becomes tan of 28,8 is equal to AB over 14. Put the tan 28,8 over 1 to make it a fraction so that we can cross multiply easily. So AB will equal to 14 tan 28,8, and that works out to 7,7 meters.